SLO, SLI, and SLA. The difference between these three and what does each of these means when it comes to DevOps and SRE world. So this is what we're going to cover in this video. I'm sure if you have worked in DevOps and cloud space, you might have heard these terms a lot. What is SLI? What is SLO? What is SLA? And you might have also gotten confused with these terminologies. But no more, because in this video, I'm going to explain you each and everything in depth using this small video. It's not going to be a long video, I promise. And by the end of this video, you should be able to clearly differentiate between each of those. So without wasting any time, let's get into the video. So let's start with understanding that the common definition of these three terms, right? SLI, SLO, and SLA. So SLI, if we talk about in the plain English, it is what your service is doing, okay? And something like your disk space utilization is 80% in the past 10 minutes, or your 95 percentile latency over the last 5 minutes is 120 milliseconds. So something that you can measure in real time and what currently the situation is right now, that is your SLI, which is service level indicator. Okay. So the last word of this acronym is indicator. That means it indicates the current situation, what exactly it is right now. And if we take the analogy of a car, you're going at 60 miles per hour, right? So that's your current service level indicator. And SLI is completely owned by engineering and SRE team, right? Then it comes SLO. SLO is service level objective. What does good enough look like? So for example, an internal target you have set for your team is 95 percentile latency over a rolling 30-day window should be less than 200 microseconds. So that's your internal target that you have set. Then this is what you want to achieve. The car analogy is the speed limit should not exceed 65 miles per hour. So that's your SLO. And it is completely owned by the product and SRE team. Now there is this term called SLA, which is service level agreement. This is the agreement, a business contract that you have as a service provider with your customer, right? So in the plain English, it is what happens if we miss, right? So when a company misses the target, misses the SLA, they have to pay some fine to the customer or some penalty or some credits to the customer, because that's the agreement that they have. For example, a company could have an SLA which says if 95 percentile latency over a calendar month goes above 300 microseconds, then the company will be paying penalty to the user. So that's an SLA between the customer and the service provider. Okay, so in car analogy, like if you are going above, let's say 90 miles per hour in a 80 miles zone, then you will get a speeding ticket of $150. So that's your fine of breaching the service level agreement. It is also called as a SLA breach, right? And it is completely owned by business and legal teams. Your SRE, your product, they don't really own it, because you ensure as a SRE or as an engineering, as a product team, you ensure that SLA is met, but then you don't get to set that target with the customer. You provide your inputs to the product team, to the SRE team, but you don't actually set the targets with the customer. Okay, it's completely owned by the business and legal teams. Now, as you can see, there are like the three layer in one system wrapped together. So on the lower layer, it's SLI, which is the observation, the current situation right now. SLO is the target that you are maintaining internally within your team. And then you have the SLA at the outer layer, which is the contract between you and the customer. You cannot have the agreement without having an SLO, right? So first you set your target within the internal team. Okay, so I should be reaching P99 latency of 100 millisecond over the period of 10 minutes, right? Then you take some buffer on top of it and you set the SLA with the customer. Okay, and then you cannot have an SLO without an SLI, right? You have to measure these targets first, right? So if you are promising your customer P99 latency over something, then you should also be tracking the P99 latency. How would you know, and how would your customers know, right? So you should have a metrics already available to measure that latency. Okay, for example, you are saying the CPU utilization should be less than 80% for the next 15 minutes for a managed service. Now you should be setting those targets. You should be setting those targets internally, and before that you should be measuring that CPU utilization internally. Okay, so it's like a reliability built from inside out. You first set SLI, then SLO, then SLA. Okay. Now we have, like, when it comes to SLI, which is your raw reality of your service, we have different concepts, right? There is availability, there is latency, there is error rate. Availability is defining, is the service up, which is, let's say, 99.9% of the requests are getting succeeded. Latency is how fast does it respond. For example, P95, for example, 95% requests are providing 200 millisecond latency. Then we have error rate. Error rate defines how often does it fail. For example, less than 0.1% requests are ending up in HTTP 500 errors. 500 is server-side errors, right? So you have the data, and based on that, you are providing the service level indicator. Okay, so currently we have 99.9% requests are getting succeeded, 95% requests have 200 millisecond latency, and only 0.1% of the requests are getting failed. So an SLI is a service level indicator, which is just a fact, right? What is currently there in your system right now. It doesn't tell you whether something is good or bad. It simply tells you exactly what it sees right now, what is happening right now. Okay, then we also discussed the concept of percentile and P50, P99, P95 latency, and what does it mean in SRE world, right? So for example, like on the left graph that you see with the blue lines, this is the average latency of all the users, right? And the graph is not that, it's not showing any anomalies because only few, like 1% of the users are getting impacted. So 1% of the users are taking few microseconds, but this is an average of all the users, right? So because 99% users are not facing any issues at all, so it is considering average as healthy. So that's why we don't measure average in SRE world. We measure something called as a percentile. Percentile is, we measure based on the top impacted users, right? For example, there is P50, which is percentile 50, which is P99, which is percentile 99, and then we have P95. So we measure all three of these. So P99, for example, we only track, or we only compare the latency of 1% users, right? Top 1% users. So that's why it's called P99. P99 plus 1, that what's make the percentile as 100, right? So only if only 1% of users are facing latency, so we compare the latency of those 1% users with each other, and then we'll see the actual issue. Okay, so let's say few users are getting 30 seconds as the latency, which is huge when it comes to request and response. When it comes to a real-time application, 30 seconds is a lot to get any response back, but we will only be trace it if we are using percentile, right? So that is why when creating graphs, dashboards, alerts, when we are creating SLOs, you would always see P99, P95, and P50 latency, right? Not the average latency of all the users. That wouldn't make sense. Okay. Then how would you pick your SLI? Okay, so we have different layers of it, right? We have availability, we have latency, we have throughput, durability. So if, for example, there is the user facing or API or front end, then you would focus on availability, latency, and throughput. If it's around the backend system, your data, your storage, then you focus on availability, latency, durability, and so on, right? So if you are not sure which SLI to pick, you should be asking, if your service broke today, what would your users be tweeting about? And that is your SLI, right? So you might have seen tweets across X where users are complaining, okay, AWS is down today or this is down today. So that comes under availability. Or if you see them complaining that my service is slow, it is taking me 30 minutes to get a response back from a web page, or it is timing out, so that's your latency, right? And so on, right? So you measure your SLI based on different metrics such as availability, latency, throughput, and durability, and it's totally based on the type of service that you are aiming for. Then so we discussed about SLI. Now SLO is setting the bar for good enough. SLO is the target that you set that you are willing to achieve. Okay. So SLI is, for example, 99 percentile latency should be less than 200 milliseconds. That's your SLI. But how would you that SLI? So this is a data point currently right now, right? So percent latency should be less than 200. But how would you measure it? That your SLO. So that means 99% of request over a 30-day rolling period. The latency of this should be less than 200 milliseconds. So that's your SLO target that you are aiming for. Okay. So SLO is the target that you set for your SLI. Okay. Now, target is never 100% because you cannot achieve 100% reliability. It is just impossible. And it will set a false narrative with the customer. It sets a false expectation with the customers, right? So you might have seen AWS, right? If you're familiar with AWS or any of the cloud services, right? Such as S3. So with S3, it guarantees 99.119% of reliability or uptime, right? Still 0.00001% is still they have kept it for any errors they might face, for any issues that they might face with the uptime, because 100% is not something that anyone can provide. So let's try to understand from Google's perspective why 100% uptime is dangerous. So Google has a service called 𝗔𝗍𝗃, which is a distributed log service, and that helps with the coordination of multiple services. Now, when you are aiming for 100% uptime, it creates a false sense of security, because if the service goes down, if any of the service goes down, the other services dependent on it or coordinating with it might not be prepared for the fallback, or they might not be ready for what to do next when the service is absent for a brief moment of time, right? And when a real outage occurs, it creates that cascading failures. Other services dependent on that service might not be prepared for the fallback or might not be prepared for the recovery, because we have set the narrative of 100% downtime, right? So that is why Google has this policy, or Google has this distributed log service as per their SRE handbook, in which they take down this 𝗔𝗍𝗃 service once in every quarter. Okay. And so that other services dependent on this, or like the services, how they're interacting with each other, that could prepare for the resiliency, that could prepare for the failure, that could have some fallback logic, right? So it's a chaos engineering that they do, so that we are not setting 100% uptime, and we make sure that we are setting the realistic timelines of a service availability. Okay, so let's talk about this term called error budget. You might have also heard about it, right? So error budget is your operational data plan. Okay, when you have the total service availability is 100%, right? And then you have your SLO. SLO is the target that we set, let's say 99.9%. The difference between that and 100% is your error budget. For example, if you have 99.9% SLO, that 0.1% is equal to something like 8.7 hours, right? So that means you are allowed to have 8.7 hours of the downtime per year. It doesn't mean that you just shut down your system for that 8.7 hours every year if it did not happen automatically. It means that you have this budget to play around with. How would you use this budget? You will use this budget, let's say by the end of the year, if you have certain amount of budget left, error budget left, so you try to experiment more, you try to deploy new code faster, you try to ship faster and do the things that had some risk earlier of the downtime. But now because you have some error budget, you can make those changes. But if you have already spent your budget, or if you don't have enough budget left by the end of the year, that means that you will be doing things like freeze releases, you will slow down, you will stabilize. And this also usually happened at the time of holiday period or at the year end, when you don't have, or like the end of the quarter when you don't have the error budget left. So mostly companies do the freeze, the code freeze and all. There are many other situations when code freeze happen. For example, for something like there is an upcoming event that is happening or many other factors, but error budget spending is also one of the reasons of code freezes. Okay, now let's talk about SLA. SLA is the contract between you as the service provider and the customer who is paying for that service. It's a legal binding contract between both the parties, and it's not written by SREs. This is a business conversation. It's mostly business and legal teams are involved in writing the SLAs. Right? But SREs define the inner rings, which is SLIs and SLOs, to ensure that team never breaches the outer ring, which is the SLA. Okay. So the one liner is, ask what happens if we miss the target, right? If the answer is nothing formal, it is an SLO. If the answer is we owe customer X amount of money, it is an SLA. So that's the main difference between SLA and SLO. Okay. So how does it look like in terms of AWS EC2 server? So your SLI is your current situation, which is, let's say, percentage of requests returning HTTP 200. That's your SLI. On top of that, you create SLO, which is 99.99% uptime. Okay. Then on top of that, you build a binding contract with the customer, which is your SLA, which is 99.99% uptime. And if you breach that SLA, you will be paying customer 10% service credit refund. Okay. So we have measure. First, you read the SLI, what is the current situation. Then you check it against the SLO, which is the comparison that you do. You also check the remaining error budget. Okay. How much budget is left? And based on that, you act whether you want to ship the feature faster, you want to freeze the code, or you want to protect the SLA. Right? So that's an operational engine that SRE follows in a continuous loop. And that is what provides a high service level reliability. All right. So just to summarize the video, SLI is what you measure, the metrics. SLO is what looks good, like the target. SLA is what happens if you miss the SLO, which is the contract. And then you have the error budget, which is how do you decide to ship the brake pedal. So you must measure before you can target and before you can guarantee the budget for imperfection. So I hope you are able to understood all the concepts, and I hope the promise that I made to you that by the end of the video, you will understand all these concepts have been fulfilled now. If you did, let me know in the comment and I will see you in the next video. Thank you so much.